Let's talk about Chapter 3, Lesson 4 of Jacob's Geometry book. In this lesson, he introduces complementary and supplementary angles, which are pretty useful in what comes ahead, what lies ahead. Okay, we're going to start with the definition of a complementary angle. And I broke it down into two parts, the conditional statement and the converse, so that you could remember how definitions work. If two angles are complementary, then the sum of their measures is 90 degrees, and its converse. If the sum of the measures of two angles is 90 degrees, then they are complementary. So that's what it means to be complementary. It seemed to me in class the other day that we could use a little more work on proving things that seem kind of easy. So let's go ahead and prove that. Prove what comes next, which is, you can kind of imagine how complementary angles might come in handy. One thing that you can figure out with them is how to compare angles to one another. So let's say you're given complements of the same angle. So if you're given angle C, and that you know that A is complementary to it, and B is also complementary to it. It doesn't really look like it, but it's close enough. So if you know that A and B are both complements of C, then what you're going to try to prove is that they have to be equal to one another. Okay? So what you're given in the proof is that A and B are complements of C. Ways to say that are A and B complement C, A and B are complements of C, A and B are complementary to angle C. There's a few different ways to say that. But let's talk about how we set up a proof. It always has to start with what you know. And there's only one thing that you know so far, and that's this. That's what you're given, that A and B are complements of angle C. And so that has to be where your proof begins. Sometimes you're given more than one thing, so you kind of have to decide when to present each set of given information. But in this case, it's straightforward. You're given one set of information. So let's see, you know, angles A and B are complements of C. Now, the reason for that is simple. It's what you're given. Every proof is going to start like this. Given. That's it. Okay, so step 2. So let's think about what we know. Because you know that something is a complement of angle C, we just went over what that means. If two angles are complementary, then the sum of their measures is 90 degrees. So that seems like a next logical step to take. So let's do that. So that means that A and C add up to 90 degrees, and B and C add up to 90 degrees. So this pair, if I add their measures up, I'll get 90 degrees. If I add these two up, and that's just by the definition of complementary. You can write out the definition of complementary for practice. For speed's sake, I'm just going to write definition of complementary. Not quite room to finish it. So then this is where what we were talking about in class comes into play. Here's what you know. You were able to build an extra step on top of what you were given. And now look at where you're trying to go. You're trying to get to a sum step down here. We don't know how many steps it is yet. You're trying to get to that, because that's what you're trying to prove. Okay, so let's think about it. You've got these two statements, and you want that one to equal that one. Looks awfully close, right? What you need to figure out is how to get there. So what if you can make A and B equal the same thing? Which looks like it's going to be pretty easy to do. Let's try that for this step. Let's just get angle A by itself. And to do that, you'd need to subtract the measure of angle C. So let's see, 90 degrees minus the measure of angle C. And let's do the same thing down here. Let's get B by itself. So the measure of angle B. And once again, we're going to subtract C to get it by itself, to get B by itself. Okay, cool. So it looks like we're actually getting closer, doesn't it? And the only thing that I did there was subtract. Okay, so the reason I was allowed to do that is the subtraction property. Okay, now, is there a way, can we get from here to here? So we've got A equaling 90 degrees minus the measure of C. We've got B equaling the 90 degrees minus the measure of C. So yes, you're there. You did it. You got down to this bottom. And what is the reason? Why can I say that that is equal to that? Well, A equals this thing. B also equals that thing. So you can just substitute at that point. So substitution. Okay, so this proof is outlined in that lesson 3, or lesson 4, I'm sorry, of chapter 3. But I hope working through it in your own head kind of helps you see that it's pretty easy, that it's a pretty straightforward proof. Or at least not too, you don't have to make too many leaps or bounds. You just need to know how to get from step to step. Okay, there's only one more definition that's in that section, and that is the other word, supplementary. Two angles are supplementary if and only if the sum of their measures is 180 degrees. Just another useful word, as you can imagine, a very similar theorem follows. The theorem for complementary angles was that complements of the same angle are equal. You can probably imagine what it's going to be for this one. Supplements of the same angle are equal. And the proof is in lesson 4 for that one as well. Okay, so I didn't get any new homework questions yet. Please send them my way if you have any. I will end with a postulate. See if you can finish the postulate. Finish that postulate. If 2 points lie in a plane, what's true? 2 points. So you should be thinking, 2 points lie in a plane. Okay, 2 points there in a line. Ooh, then the line that contains them lies in that plane. Okay, great. See you in class on Friday.